video, we are going to talk about Friedel-Crafts alkylation. The next, the third reaction that we are going to talk about, because in the previous two videos we covered halogenation, and as the first and the second reaction that we covered was nitration. Now the third reaction that we are covering in this video is Friedel-Crafts alkylation. Again, this is also electrophilic substitution reaction, which is basically the only reaction that benzene can undergo. Okay, now the conditions for this reaction are very important. 1 to 2 mark questions come on it. So basically, let's get started. Conditions and the reagents both actually. Condition is simple. It's just we need to heat the mixture, and the reagents in this reaction are Rx. Rx basically represents an alkyl halide. An alkyl halide. Okay, what is an alkyl halide? Alkyl halide is basically a compound that is made up of an alkyl group and a halogen atom. So the R over here, the R represents an alkyl group. Alkyl group is any group which has a general formula of CnH2n plus 1. Okay, the general formula. C represents the carbon, H represents the hydrogen, N is any integer. So for example, if the value of N is 1, so CH3 will be the alkyl group. If the value of N is 2, C2H5 will be the alkyl group. This CH3 one carbon alkyl group is known as the methyl group. The 2 carbon alkyl group is known as the ethyl group, and so on. Propyl and then butyl and so on. Okay, now the R represents an alkyl group and the X over here represents a halogen atom. Halogen is any group 7 element, as you guys know. So halogen, it can be chlorine, can be bromine, iodine, etc. Okay, well, usually these three elements are given in the past year paper. So chlorine, bromine, or iodine. Well, iodine very occasionally, but chlorine and bromine are mostly asked. Okay, so any alkyl halide, for example, CH3, chloromethyl chloride, or chloromethane. You can pronounce it either way, chloroethane or ethyl chloride. Two ways to pronounce it. Well, the naming is not important. It's not that important. Now let's go on to the reactions. ALX3 is used as a catalyst, where X again represents a halogen atom. So X can be chlorine. So when X is chlorine, it becomes AlCl3. When X is bromine, it becomes AlBr3, etc. Okay, so AlCl3, AlBr3, either of them can be used as the catalyst in it. And heat, obviously heating is required. So basically the conditions and the reagents collectively carry 1 to 2 marks. So learn these conditions. So the alkyl halide, the AlCl3 or the AlBr3 catalyst, and heat are the conditions and the reagents. Okay, now let's move forward. The overall equation, the general equation of Friedel-Crafts alkylation is over here and represented in the red. Benzene ring reacting with an alkyl halide, Rx, which is any of the alkyl halides, in presence of AlX3 catalyst, and heat, we get a monosubstituted benzene ring with R, the alkyl group, being attached as a substituent, and the X, the halogen atom, then combines with the hydrogen atom, which is substituted or which is removed by the R group from the benzene ring, and it combines with the X to form the halogen acid as a byproduct. Okay, so this is basically a general equation for all the Friedel-Crafts alkylation reactions. So let's take an example now. For example, I have this benzene ring over here, and this reacts with methyl chloride or chloromethane, whatever the way you want to pronounce it, and in presence of AlCl3 catalyst, and heating it, the product that we'll get would be methylbenzene plus the halogen atom will then combine with the hydrogen atom forming HCl, the halogen acid. So the monosubstituted benzene derivative is the methylbenzene, methylbenzene, and HCl is their byproduct. Okay, this is the methylbenzene over here, HCl. Okay, so methylbenzene as our monosubstituted derivative and HCl as the byproduct. Okay, now let's go on to the detailed mechanism, which is usually asked for 4 to 5 marks. The examiner asks to describe the mechanism. So now this is what you're going to write in their description. Whenever it's asked to describe the mechanism for 4 to 5 marks, you will write the answer as follow. The first step again for all the electrophilic substitution reactions is common, which is the generation of electrophile. Generation of the electrophile. Now, how to generate the electrophile? Basically, this catalyst over here, the AlCl3 catalyst, helps in generation of the electrophile. It combines with the CH3Cl with the alkyl halide, forming AlCl4 negative. Basically, it removes the chlorine atom from the alkyl halide and forms the carbocation CH3 positive. This CH3 positive is our electrophile. Electrophile. Now this electrophile will attack the benzene ring. The second step is the electrophilic attack. The benzene ring has a region of high electron density above and below the ring. This CH3 will come over here with its positive charge. Now again, we have to be very careful with drawing the curly arrows. Because the examiner is very strict while dealing the curly arrows. They must begin from the benzene ring, from the center or anywhere inside of the benzene ring, and must end on the electrophile. The arrow should not be pointing anywhere else, but rather should be pointed on the carbon atom. Okay, then after this, the second step is the formation of the intermediate. Okay, now in forming the intermediate, two bonds need to be displayed. One bond is the CH3 bond, the bond with the CH3, and the other bond is the bond with the hydrogen atom of benzene. We are going to display one of the hydrogen atoms of benzene. Now, since two of the electrons from inside of benzene are used to form the dative bond, the benzene ring inside of it is disturbed, it is distorted, it is broken, and the rest of the ring will appear as a crescent shape, and this ring must cover the remaining 5 carbon atoms. These 1, 2, 3, 4, and 5. These 5, 1, 2, 3, 4, and 5. This ring must start from the immediate neighbor of this carbon containing the CH3 group attached. It must begin from the immediate neighbor carbon atom and must end on the second immediate neighbor of this ring over here. So basically you don't need to draw the red part, okay, but this black part is important. And since it formed a dative bond, and once a dative bond is formed, it behaves as a normal covalent bond. So this benzene ring has lost one electron to the methyl group, because after forming the dative bond, the covalent bond would act as if one of the two electrons belong to the CH3 group and the other electron remains with benzene. So therefore the benzene ring will get a positive charge. Okay, now after getting this positive charge, this carbon hydrogen bond will get polarized and will break again heterolytically. Now this curly arrow is also important. It must begin from the carbon hydrogen bond and must end inside of the benzene ring. The crescent must end inside of this crescent because curly arrows are very important. Okay, so be very careful with it. Representing the heterolytic fission of this bond. Heterolytic fission. Okay, you don't need to write this down. You don't need to write this down, but you don't need to write the heterolytic fission word, but this bond breakage is known as heterolytic fission. And after this, once the bond is broken, the benzene ring, the delocalized pi electron system inside the benzene is restored, and the CH3 stays on the benzene, and this carbon hydrogen bond breaks, giving out H positive as the byproduct. Okay, now once the H positive, so over here we have our major product, methylbenzene, and the hydrogen atom that we have will combine with AlCl4 negative that came initially over here, AlCl4 negative that came as a byproduct while generating this electrophile. The hydrogen atom will combine with it, and it will remove a chlorine atom from the AlCl3 and from the AlCl4 negative, and hence AlCl3 will be left, AlCl3 would be left, and HCl will be formed as the byproduct. This AlCl3 over here, this AlCl3 over here, we saw it in the beginning. We saw it over here while generating the electrophile. So again, this AlCl3, when, so what species is used to start a reaction but is regenerated in the end, but is left chemically unchanged in the end? It's basically a catalyst. So it's proved again that AlCl3 acts as a catalyst in this reaction. Okay, so catalyst, basically it does take part in a chemical reaction but is chemically unchanged at the end of the reaction. It may change physically, but chemically the catalyst remains unchanged. So this was the Friedel-Crafts alkylation reaction, and Friedel-Crafts alkylation reaction is basically done so as to add the alkyl chain, the R group, onto the benzene ring. Okay, so if I were to take more than one carbon atom alkyl group over here, so the mono substituted, the substituent of this benzene ring would have contained more than one carbon atoms. So we can generate a mono substituted benzene derivative with more than one carbon atoms as the substituent. Okay, so thank you so much, guys. So meet you all in the next video on Friedel-Crafts acylation.